On this next one, you'll see a lot of these types of problems now that you know how to do area. We're asked for total area. And of course, because this one happens to be an odd function, as we discussed earlier in this lesson, we know that if we look at the area, it will actually have an area of 0 if we just start adding up the parts, because this left part is positive, this right part is negative, and they'll cancel each other out. So if I want to find the true total area, I'm going to have to separate it into 0, just kidding, -3 to 0, and 0 to 3. Now, how did I know that it actually graphed that? Well, I do need to do that first, actually. So when I come back over here and I look at the original function and I set it equal to 0, I'll end up having 3 x-intercepts. It factors very nicely for me. So I get x equals 0, 3, and -3, so that I knew exactly what was happening when I graphed this. And that was important. So that's why I started with the graph first. And in case you wondered how I knew all of that, there's the big secret. So going back to the integration piece, so I have to look at the positive part, this is the left piece, separate from the negative part, so that they don't just cancel each other out. As a matter of fact, I know on this side I'm going to have to absolute value it when I'm done, because I do know for a fact that it's going to be negative. Okay, so pause right here and see if you can do the calculations to get the numbers, and then you can turn me back on and see if you got it correct. So check your math, see if you got to 81 halves. And on to the last problem. So some of these problems are my favorite types because they're like puzzles. So I know something here about the original function and I want to find something else. And of course right now I have the first derivative of that original function, so I've got to get it backwards. So I'm going to take the antiderivative first, and so I'll end up with antiderivative is just f of x, and I have to evaluate it from 0 to 5. Remember, I'm not putting the plus c just because I know that it's going to cancel out when I substitute in. And so this is going to give me f of 5 minus f of 0. And so, of course, I know that if I take the antiderivative, it's supposed to equal, so this is the antiderivative, it's supposed to equal 15. And I know that this quantity is 4. So what I have now is 15 equals 4 minus f of 0. And when I solve for f of 0, I get -11. Isn't that a cool problem? I love that problem. It makes an easy multiple choice. Okay, that's all for this lesson, guys. See you tomorrow.